So, order of operations, inside the parentheses. You can't combine 4x minus 2. They're not like terms. So we could just drop the parentheses and subtract, but you can't just drop parentheses when you have a subtraction problem. You have to distribute the negative to both terms. You're subtracting the whole thing. It's like having -1 times that parenthesis. So you're going to multiply -1 into the parentheses, which means these two signs will change. Positive 4x comes out as a negative 4x. -2 is going to come out as a positive 2. You distribute the negative to both terms, and the signs will change. If it was a plus, you distribute a positive, the signs don't change. A positive times a positive is still a positive 4x. A positive times a -2 is still a -2. If it's an addition part, the signs won't change. But when it's a negative, the signs will. So from left to right, I can't combine -x and a 6. So -x plus a 6 minus positive 4x is now -4x. Minus a -2 is now a positive 2. And now you combine like terms. And this is what drives me up the wall. I'll see this happen. Okay, I'm going to combine the x and the -4. So I see this happen. They add 4x to both. That is when you're working two sides of an equation. What you just did to this question was you added 8x to it. Out of the blue. On a whim. Where did that 8x come from? Because now it's a completely different problem. The outcome is going to be completely different. If you're solving an equation, then you would add the same thing to both sides because you got to keep the equal balanced. Whatever I add to the right, I got to add to the left, or your left, my right, your left, my left, your right. To keep it balanced, multiply both sides with the same number, divide both sides with the same number. Not add a number to one side and nothing to the other side. So it's like going down a shopping aisle, grocery store aisle, and combining like terms. I have these -4x or -1x, and I have -4x's, and I'm put them all in the -x basket. -1 of them and -4 of them makes -5x's. Her multiplier broke up with 1, and then she broke up with 4 more people. So now she has 5 -x's. She just has to break with 2 more, and then she'll have 7 evil x's. You know what I'm talking about. Saw that when it first came out. Yeah, it's playing out all trading thing. Saw that at Comic-Con 2011, 2012. The whole cast was there. Yeah, cool. My daughter shouts out Michael Cera, right? Yeah. Michael Cera had my babies. I think she was 14. And then 6 and a 2, 6 plus 2, that's a plus 8. You can't go any further because they're not like terms. You have to simplify it first, completely. Okay. Here. Parentheses, 2y minus 3x, we can't do anything with that. But before I add, I have to multiply. This is multiplication. So bring it down, 5y. Now we're going to distribute. Positive 2 times 2y, that's positive 4y. And then positive 2 times a negative 3x, that's a negative 6x, and then plus 7x. From left to right, you do the problem, and you bring it down from top to bottom. So reworking the problem, I do whatever I can with this first step, multiplication, distribute the 2. And now I'm going to combine my like terms. So from left to right, I have these 5y and another positive 4y. So 5y and 4y add up to 9y. And then I have a negative 6x and a positive 7x. So what does that add up to? There's positive x. And if you left it like that, I'd give you full credit. But when we write any kind of expression, if we can arrange it in a better way, we want to. The alphabet has an order. Numbers have an order. We want the biggest degree if we have a higher degree, x squared, x to the first, x to the 0. We want the degrees to go down from biggest to small. And if we can put our variables from an alphabetical order, that actually helps arrange things because we have to maybe take another step with it. So this actually would be a better way to write it in case we had to go somewhere else with it. But they're both true. Thank you to the commutative property of addition. I'm sorry, I got like 45 minutes of sleep last night. So I'll be blabbering all day long. And I got a committee meeting from 3 to 5. So I should call it Uber. I'll take the high speed route. I just gotta wait another 15 minutes. Okay. So now we have a whole lot going on. Parentheses first. So when you see something like this, don't stress over it. Same steps apply. Take it one step at a time. We're over here. We go, can't do anything with 7 minus 2x. You can't do anything with 2x minus 5. So to drop the parentheses, we're going to do the operation in front. Bring down the 3. We're going to distribute the negative. The negative is going to change the sign. Positive 7 will come out negative. Negative 2x will come out positive. Minus positive 7, so negative 7. Minus negative 2x, so positive 2x. When we add, the signs don't change. Plus a positive 2x is still positive 2x. Plus a negative 5 is still minus 5. And then you have a minus 12. And since we're trying to put this in the right order, I would go and try to find all the x's first, the variables. I have 2x plus 2x, that's a total of 4x. So the x's are done. And now we're just going to combine from left to right, add, subtract the constant. 3 minus 7. So that's what? Negative 4. And then a negative 4 minus 5. Negative 9. And then a negative 9 minus 12. Negative 21. 3 minus 7 minus 5 minus 12. So 3 minus 7, that's negative 4 minus 5 minus 12. Negative 4 minus 5, it's a negative 9 minus 12. 9 negatives and 12 negatives is a total of 21 negatives. But you also get to use a calculator. You can just punch in 3 minus 7 minus 5 minus 12. You should get negative 21 on screen. So tell me, was the test just like the review sheet? Yeah. Thank you. So did you prepare for it as if it were like the review sheet? So no surprises. Again, I have not even looked at any of the tests to see, what's going on. I don't know why I came over here. I don't have to go over here. Go back. Wow, I'm going to be punchy all day long. And this is not why I didn't get this. This is, I wasn't goofing off. This is just a coincidence that it happened. I deal with a lot of pain, so I couldn't sleep because of the pain, because I've been working from my desk probably from 2 o'clock until about 12 midnight, 12:30 last night. So every time I tried to go to sleep, I couldn't get to sleep because then the dog would start to whimper. So it was around 3:30 that I was still trying to fall asleep. The Dodgers are playing the Cubs in Tokyo to open up baseball season. The game started at 3 o'clock in the morning. Here, they're playing over there. So I turn it off. My dogs are conditioned that whenever the Dodgers hit a home run, we do the Dodger game. So when they hear a big crack of the bat and the crowd to cheer, they look at me. If they see me put my hands up like this, they jump down and they start to twirl. I don't have to say a word. But why do they do that? Because they get treats after that. That's the whole thing. You offer enough food, then it will do anything. Solve an equation. If I can only get them to close the door after they come in. All we got to do is get x by itself. I don't care if you can look at it and figure out, oh, the answer is 23. Show the word. X minus 5, how do we undo subtraction? We add. So you don't have to show this work when you add 5 to both sides. And this is what I mean by show the work. You can't just go plus 5 on one side. You can't just go 5. 5. Well, what are you doing with that 5? Eddie? I don't know. I don't see any operation. I just see a 5. Okay, if I just put a random 5 up on the board, I mean, what the heck does that 5 mean? You know, if I go 5 with a 5 and I go, hey, I could go, that's a 10, maybe it's a 0, maybe it's a 25, how about a 1? Don't know. Unless you put an operation. So if you're going to add 5 to both sides, you got to show that work. X minus 5 plus 5 just gives us X. 18 plus 5 is 23. Put your answer bottom of the box. Versus the next one, negative 5 times y equals 110. So that's a multiplication problem. So to undo negative 5 times y, what are we going to do? This time we have to divide. We divide by negative 5. Because again, we want positive y. So to undo negative 5 times y, we divide by negative 5 on both sides. And again, this is going to get a minus 1 point if I see this. Because that, I don't know what that means. Well, I know what it means. It means you're lazy. Or you had a teacher who taught you that and said, well, this is how lazy people do it. That's not dividing both sides by 5. I don't know what that is. Because as soon as I reduce, okay, they go into each other. Then I have nothing going into the 110 because it reduced already. It's gone. You keep the equation balanced. You divide this side by negative 5. You divide that side by negative 5. So that reduces. You get positive y. And you simplify. Positive over a negative is a negative. Now, some of you are doing this when you reduce your fractions. You go, all right, I'm going to divide by 5, divide by 5. This is not how you simplify fractions. You may have been taught this, but it's not how you reduce fractions. 110 divided by 5 is equal to 20, 22, and negative 5 divided by 5 would be a -1, so 22 over -1, -22. Did it work? Yes. But it's not the way you reduce fractions. Because you're gonna have to reduce fractions that look like this. That's the five. And the only way to reduce that fraction is factoring. So if you can't factor numbers, how are we going to factor polynomials? So you got to show the factoring. Get used to it. You're going to have to solve quadratic equations. And the quickest, easiest, nicest way to solve a quadratic equation, if it factors, factor it. It's the nicest way to get to the correct answer, if it factors. If it doesn't factor, we have other tools. This is going to equal x plus 1 over x minus 4. Because the numerator is x plus 4 times x plus 1, and the denominator is x plus 4 times x minus 4. X plus 4 over x plus 4 reduces. There's my common factor. So when I said we're going to be doing a correct on factoring only, yeah, we will. Because 2.4, the first thing you have to be able to do is solve a quadratic equation with factors. On the chapter 2 test, there are specific questions that say, you must solve this one with factors. You got to solve this one using this method. You got to solve this one using this method. And then it says, solve it any way you want. Show your work. As long as it's an algebraic method, you got to show your work. And I'm going to keep saying this all over and over and over again. Try factoring. So this it's not gonna work right there. So you want to start working on your factoring. So in this case, I'm going to take care of the sign. I know it's going to be a negative, and then I see that 5 goes into each one. This is just 5 times 22 over -5. The 5 is reduced. 22 over -1 is -22. Show that factoring. Get used to doing it like this, where you factor it and reduce the common factors. You'll be much better off for it. Do you have to? Well, why am I going over this like I'm begging you to? I'm not going to make you with this. I'm going to be annoyed when you do it the other way, because I know we're going to take it to a different place. Okay. All right. Let's see if we can get this next one. 4 times x equals 0. We have to do what? Divide by 4. So this is what I see sometimes. I'll see, okay, I'm dividing by, and I'll see divide by 4x. We're solving for x. We don't want to divide by the x. We want the x to be left on the left side. We don't want the x going over anywhere. Because if you do this, 4x divided by 4x, now you have 1 equals, what's 0 divided by 4x? What's 0 over a number? I even had it on the board when you took your test. 0. 1 equals 0? I don't think so. But you're not supposed to divide by the x. We want to solve for x. So the only thing you're dividing by is the 4. So now you have x equals 0 over 4, which is 0. which needs to make a little bit of sense. You had 4 times a number equal to 0. The only way you're going to be able to multiply 4 times what number to get a 0? It has to be 0. That is called the zero product property. I just got done saying the nicest, easiest way to solve a quadratic equation is if we can factor it. We want to solve this. What makes this equation equal to 0? So we want to factor it. This factors, and I showed you already, this is x plus 4 times x plus 1. I'm not going to show you how to do that yet. Maybe you know, maybe you don't. But I'll prove it to you. If I distribute, x times x would give me an x squared. X times 1 gives me an x. 4 times x gives me a 4x. And 4 times 1 gives me a 4. X squared. X plus 4x is 5x in the middle. And then a plus 4. So this is the factoring of that when I multiply it back together. So I know I factored it correctly. But here's what we're after. Here's what we're taking. The key to solving this problem is you factor it. Now, what you just did on that number 6, and this is what the co-rep is for, to give you information to preload what we will be doing. We're solving equations, but we're going to take it to another level. We're not just going to be solving this kind. You know, x minus 5 equals 18. You know, we wish. So, put it up. We just had 4 times x equals 0. So 4 times a number equals 0. Well, the only thing that's going to make 4 into a 0, that x had to be the 0. So here's the rule. If a times b is equal to 0. If I multiply 2 things together and I get a 0, then either a equals 0 or the b has to equal 0. Because the only way you can multiply something together and get 0 is because one of them is 0. That's why we factor. The only way you can multiply 2 values together and get a 0 is because one of them has to be the 0. So this is not multiplication. That's why we factor. Now, this times this is 0. So either the x plus 4 is the 0 or the x plus 1 is the 0. So now I have 2 easier equations to solve. Subtract 4. So this x, if it's the 0, would be a negative 4. 4. Subtract 1. This x would equal negative 1. So this equation has 2 answers, a negative 4 or a negative 1. Both of those would make the equation equal to 0. Now, the nice thing about chapter 2 is you can always plug it in and see if you got it right. If I let x equal negative 4, let's see if we get 0. Here we go. This is straight chapter 1 substitution. F of negative 4. When I plug in the negative, what do I need to make sure happens? You have to be really careful, so you got to put the, what you got to do? All right, substitute negative 4. parentheses. So -4 going in, we get -4, then we're gonna square it, plus 5 times the -4, and then a +4 is supposed to make 0. So when I square -4 times -4, I get positive 16. 5 times -4, that's a -20, and then a +4 is supposed to be a 0. 16 minus 20 is -4 plus 4. And -4 plus 4, I get 0 equals 0. So when I plug in -4, it makes the equation true. And if I plug in -1, so we get parentheses -1 squared plus 5 times -1 plus 4 equals 0. So we get +1. 5 times -1 is -5 plus 4. Supposed to be 0. 1 minus 5 is -4 plus 4. -4 plus 4, we get 0 equals 0. That's why we need to know how to factor. To answer. The fundamental theorem of algebra. We have fundamental theorems for like all the time. Fundamental theorem, calculus, algebra. Fundamental theorem of algebra says for an equation of x to the n, there is at most n unique solutions. So when we have a times x plus b equals some number c, first degree, one answer. Ax squared plus bx plus c, okay? And let's just say equals 0. A second degree problem should have at most 2 answers. Ax to the third plus bx squared plus cx plus d equals 0. X to the third, 3 answers. X to the fourth would have possible 4 answers. X to the fifth, x to the 27, a possible 27 different answers. Okay. You're not going to get that past x to the 27. You might get an x to the third, you might get x to the fifth. And how we find those, we have different techniques to kind of whittle it down, to take equations apart. Because that's what STEM does. That last one on that set, right here, fresh off of, let's see, what was that? That was off of, is there a no solution? Keep in mind that we weren't solving equations. Was that on the quiz? Yeah, that's probably not. Maybe when I wake up on it. So simplify, we would distribute 3 times x. 3 times -9 is -27. And over here, 3x minus 27. You want to get x on one side. Focus on the variables first. Get your variables on one side, then focus on the numbers. So we can either bring x to the left or to the right. And in this case, it's not going to matter because look what happens. If I bring the x's to the left, I would subtract 3x from both sides. And then make sure you see that this 3x minus 3x, no more x's. 3x minus 3x, no more x's. You don't have one X, you don't put it, you have nothing. The X's have canceled out. When the X's cancel out of an equation, you check what's left over. Your leftovers are -27 equal to -27. If the leftovers are true, then the solution is all real numbers. Because when the X's cancel out, what that means is it doesn't matter what you plug in for X, it's always going to cancel out. What we have left over is always going to be a true value, a true statement. No matter what I plug in, it's going to work. So everything works. All real numbers work. If it was 3 times X plus 9 equal 3X minus 27, we have 3X plus 27 equal to 3X minus 27. Subtract 3X. This time, the X's still cancel out, but the leftover is a positive 27 equal to a negative 27, which is false. That's not true. When the leftovers are false, then we have no solution. There's nothing I can plug in that's going to make the left side equal to the right side. So if you're solving an equation and you gather all your X's on one side, and that's the key, you want to focus on getting your value, your variable to one side first. Then you take care of the numbers. You got to have, when you approach a problem, you got to have a plan. You can't just do things randomly. Step 1, and I'll write down, write these things down as steps. Step 1, simplify both sides first. Step 2, gather your variables on one side and then do your constants on the other side. Variables on one side, take care of the variables first, then put the constants on the other side. Even if I kept going, let's get the constants on one side. So I either take the 27 to the right or bring this negative 27 to the left. If I bring the negative 27, I would add 27. 27 plus 27, that's 54. But what do I have on the right side? 0, and it's still false. My leftovers are still false. So it's still no solution. Got to be careful. Unsolved. Oh, I just gave away number 11. Look, these, like, that's plus 9, 3 of 5, 23. That means 8, 9, and 10. So simplify both sides first. Now we have a whole bunch of stuff on number 8. Number 9, it's got fractions. And number 10, it's got decimals. Well, these are all like your 2.1 homework. Step 1, simplify both sides. So on this side, from left to right. I think I have one that's not onto a little bit there. Yeah. So 3 times positive 4x is 12x. 3 times negative 2, that's a minus 6. What's this negative gonna do to that parenthesis? Gonna change the sign. A negative times positive 5x is a negative 5x. A negative times a negative 8, that's a positive 8. Every little thing, just take care of it one thing at a time, because if you mess up this sign right here, a negative times -8, and you put -8, there's no way you're gonna get the right answer. You make that mistake right here, there's no way to recover because you got the wrong value here. And then equals, this is not multiplication, and I will see some of you go 8 times both of them, because you see an 8 and you see a parentheses, but it has addition in between, it's addition. And when I add, that's no big deal because the signs aren't gonna change, it's gonna be 8 plus positive 2x, so positive 2x, plus -3, so that's just -3. So I've gotten rid of the parentheses. Do not write this down. But this is where I see mistakes. When you try to, two things, when you try to simplify it, I see this happen. I want to combine the 12x and the 5x. So I will see this. I'm going to add 5x to both. Well, what just happened, 10x was added to this left side, nothing to the right. So we added 10x to the left side, and it didn't stay balanced because we put nothing on the right. You're not trying to undo this -5x. We're going to combine it with this positive 12x. You're going down that supermarket aisle and you're gathering up the x's. I have 12 x's and then -5 x's. So 12 x's and a -5 x's is a positive 7 x's. Okay. The other mistake I will see is getting ahead. Going on to the step where you want to get x's on one side, numbers on the other, before you finish simplifying. You'll see a -5x, so I will see students, I'm going to add 5x to both sides right now. So you've taken the 5x from the left, you put it on the right, but you still have the 12x over here. You want to simplify both sides first, completely. Clean it up before you start trying to move things from left to right. That's your strategy. You can't do it randomly. So 12x minus 5x is 7x. And then you have a -6 and a +8. What's -6 and +8? +2. So the left side is now 7x plus 2. We clean it up. Equals. On the right side, x should go first. The only x term we have is a +2x. And then your constants, and 8 minus 3 is 8. What kind of value? -5 plus 5 times 5 divided by 5 plus 5. Simplify both sides first. Now we're going to get all the variables on one side. Focus on the variables first. So you have a choice. I can either take the variable 7x, take it to the right. If I take it to the right, I have to subtract 7x from both sides. So 2 minus 7, I'm going to end up with -5 x's on the left, on the right side. Or I can subtract 2x from both sides. 7x minus 2x would be +5. It doesn't matter. But think about both moves before you actually make your move. It's a game of chess, game of checkers. After I make this move, before you take your finger off it, off the checker piece, what's going to happen next? Do I want to do this or should I try something else? So if you want to bring the 2x to the left, and take 7x to the right, to the left, to the right. 7x that way? So you want to subtract 7x. So now on the left side, we have a 2 equal to 2x minus 7x, that's -5x, and then +5. Since you took the x's to the right, now you have to bring this 5 to the left. So that means you have to subtract 5. 2 minus 5, negative 3, equals negative 5x. So we want positive x. Right now we have negative 5 times x. What's the next step? Divide by negative 5. So x is equal to a negative over a negative is a positive. It will equal a positive 3 over 5. And that's what goes right there. I was surprised you wanted to go to the right because you got the negative there. Most people were going to go to the left because it's positive. That's all right. So it's conventional. Just keep track of the negatives. Those of you who put your negatives like this, like real small little kind of, you're going to forget that there was a negative there. Fractions. Again, when I write up the steps at 10, I'm going to put up step 1, simplify completely, undo fractions. If you have fractions, undo fractions by multiplying every term by the least common denominator. So you have a 4, 2, and a 3. What's the least common denominator that will undo a 4, 2, and a 3? 12. So if you look at each one individually, just a 4 and a 2 and then a 3, the first number that 4 and 2 can, they can divide into would be a 4. 4 goes into 4 and 2 goes into 4. But here it comes the 3. The first number that 4 and 3 can go into is a 12. So the first number that all 3 of them divide equally is a 12. So I'm going to multiply every term by 12. The purpose of multiplying by 12 is to undo the denominator, to undo the fraction. 4 goes into 12 3 times. 3 times 3y, that's a 9y. Minus 2 goes into 12 6 times. 6 times 5 is 30. Equals 3 goes into 12 4 times. 8 times 4 is 32. No more fractions. Simplify both sides. Well, you can't go any further than this. Both sides are simplified. Then we want to separate the variable from the constant. Gather all the variables on one side. Well, that's the only term of the variable, so that's done. It's on the left. So that means we're going to take the constant to the right. We're going to add 30 to both sides. 9y is equal to 62. And then you undo multiplication, divide by 9. Simplify completely. Well, 62 and 9 have no common factors. Final answer is 62 over 9. It's reduced. No decimals. Don't waste the time changing it into a mixed number. Don't risk the time of changing it to a mixed number just in case you get it wrong, because that's right. Just make sure it's simplified. Reduce those terms. And then when you're dealing with decimals, calculator's kind of nice. But hopefully you don't have to have one. A negative times a positive is going to be a negative. 0.3, that's 30 cents. 30 cents times 2 would be 60 cents. So this is going to be negative 0.6x. Negative times a positive, that's going to be a negative. 30 cents times 5, that's $1.50. So it's a negative 1.5 equals 0.7 is 70 cents. So 0.7 times 3 would be $2.10, positive 2.1. And then a positive times a negative is a negative 0.7 times x. I mean, it's not like it's a 4-digit decimal. It's just, it's money. Simplify both sides completely. You can't go any further because you can't combine this x term with a constant, and you can't combine those two with a constant and an x term. So now we want to gather the variables on one side. So we're either going to bring the x's to the left or take the x's to the right. So I'm either going to add 0.6x to both sides, or I'm going to add 0.7x to both sides. So we're going to the left and to the right. Right. Go with that. What's bigger, 70 cents or 60 cents? 70 cents is bigger than 60 cents. Boy, would I like to do some money exchange with you? You have 2 cents for a 5? We add 0.7x. And I see this one get messed up. I have negative 60 cents times x plus 70 cents times x. So what's 70 cents take away 60 cents? 10 cents. So it's positive 0.1x. I still have minus $1.50 equals 2.1. So since the x's are on the left, I have to take the negative 1.5 to the right. What do? Add $1.50 to both sides. Not that. That's division. Add $1.50 to both sides. So I'm left with 0.1 times x equals $3.60. 1 plus 5 is 6. Decimal point 3. 2 plus 1 is 3. But 0.1 times x equals 3.6. What's that? Divide by 20. 0.1. And x is equal to 36. Now, you can use your calculator. It means 3.6 divided by 41. But again, let's think about money. 3.6, $3.60. 0.1 is a dime. How many dimes are in $3.60? There are 36 dimes in $3.60. One dime goes into $3.60. 36 dimes. A lot of that is what you're going to see on the 2.1 and 2.2 homework. Okay. So that's where we're going to be at 10.